Hello everybody, my name is Kiran. I am working as an assistant professor in the department of EEE Anits. I welcome you all to my series of lecture on the concept of network topology. In my previous two lectures, I discussed what are the basic terminologies involved in the concept of network topology. I also discussed the procedure to construct incident matrix and tie-set matrix. In today's lecture, we are going to see the procedure of how to construct a cut set matrix and how to write equilibrium equations related to that. First, a cut set of a graph is formed by one twig associated with many links. So we can see it is quite the contrary when compared to tie set matrix. In order to form a tie set, there we previously considered only one link and any twigs. Coming to cut set, it is quite opposite. So while forming cut set, one should remember that you should consider only one twig and can consider any number of links. Every twig that is being chosen of a following tree, so there exists one cut set. So every cut set will be associated with a twig. So that means that the number of cut sets will be equal to number of twigs of a given tree. Order of the cut set matrix is n minus 1 cross b, where n minus is number of twigs and b is the number of branches. And the cut set direction will be same as the twig direction. The procedure is, first we need to find a graph of a given network, assign the corresponding nodes and branches, and make it oriented. That is, some arbitrary direction we need to assume in each branch. Then select a suitable tree and form the cut sets according to our rule. That is, it should contain only one twig and any number of links. And depending upon the direction of twig, the cut set direction is also decided. So if they both have, say, if the branch direction as well as cut set direction are in the same direction, then +1 is entered. If the branch direction as well as cut set direction are opposite to each one another, then it is -1. If they are nowhere related, it is 0. So for this graph, we are supposed to find cut set matrix. So assuming branches 1 to 5 as tree, and the remaining branches will be links. So here I have 2 links and 3 twigs. So the number of cut sets is equal to number of twigs, so it will be 3. So I want you all to listen very carefully. So depending upon number of twigs, we will get number of cut set. So twig, this is one twig, this is one twig, this is one twig, and fifth one is another twig. Okay, while forming cut set, one should remember that it should cut only one twig and can cut any number of branches. Okay, remember, if I consider this as a cut, can I consider this as a cut set? No, because how many twigs it is cutting? 2 twigs. But the rule is, while forming a cut set, it should cut only one twig. So this I cannot consider as twig. Okay, so let me consider this one. Okay, so it is not violating our rule, because the cut set that we need to form should cut only one twig and any number of links, isn't it? So here it is cutting one twig, one link. So here also I can consider this as one cut set, because here it is cutting one twig and 2 links. Okay, and so this is the cut set related to second twig, and this is the cut set related to fifth twig. Coming to the first twig, I can consider a cut set in this manner, because Remember, while drawing a cut set, a cut set is nothing but it should cut my graph into two parts. Need not be equal parts, but into two parts. While drawing a cut set, you should not stop the cut set in between. Okay, draw it in full semicircle such that you are cutting the entire graph into two parts. Okay, and the direction of this cut set will be same as the twig direction. So this cut set direction will be in this direction because twig is in that direction. Since twig 1 is towards the direction is towards the right side, the cut set direction will also be towards the right side. Okay, since the fifth twig direction is towards upwards, this cut set direction will also must be considered in that direction only. Okay, so this is how we choose a cut set and its orientation. Okay, similarly, if I consider second twig, since the second twig direction is towards the right side, the cut set that I have considered because of second twig should also have the same direction. So this is how I considered, or this is how we construct a cut set for a given graph, and this is how we give the direction to that particular cut set. Okay, so let me clear this. So let me show you precisely how you can draw a cut set. So this is what we have already seen, isn't it? So the direction of the cut set, so this I have named as C1, C2 and C3. So cut set C1, you can see that direction is in the same direction as twig 1. C2 cut set, I have considered the direction as the same direction as twig 2, and cut set C3 direction I have considered as the same direction as twig 5. Now considering the forming the cut set matrix, here while remember, first twigs should be entered, then links should be entered. Okay, here also it is quite the contrary when compared to tie set, isn't it? While forming tie set matrix, first link should be entered, then twigs. And coming to cut set matrix, it's quite the opposite. First twigs should be entered, then links. Okay, so the twigs are 1, 2 and 5, links are 3 and 4. Whatever order you are following for twigs, the same order we should follow for cut sets also. Okay, so the cut set related to first twig is C1, so I have entered C1 first. The cut set related to second twig is C2, then I have entered C2. The cut set related to fifth twig is C3, then I have entered C3. So this is how the entries will be done for cut set matrix. C1 and twig 1 are in same direction, so +1. Twig 2 and C1 are nowhere related, so 0. C1 and fifth twig are also nowhere related, 0. C1 and third link are in the same direction. You can see here in the diagram, so it is in the in this direction, and third also is in the same direction. Okay, so +1. Fourth is in the opposite direction, so it is -1. Coming to cut set 2, C2, C2 and 1 are nowhere related, 0. C2 and twig 2 are in the same direction, +1. C2 and fifth twig are nowhere related, 0. First link, third link is in the same direction as C2, so +1. Fourth link is nowhere related to C2, 0. Coming to cut set 3, C3. C3 is nowhere related to 1, so 0. C1 is nowhere related, C3. C3 is nowhere related to twig 1, so it is 0. C3 is nowhere related to C2, so again it is 0. C3 is in the same direction as 5, so it is +1. third link is also in the same direction so as C3, so it is +1. Fourth link is in opposite direction of cut set C3, so it is -1. So this is how I can construct a cut set matrix for a given graph. The next example, here also consider 1, 2, 3, 6 branches as tree, and the remaining are considered as links. So since I have four twigs, 1, 2, 3 and 6, 4 twigs I have, so the number of cut sets will also be 4. So here also first let me consider first twig, so I can draw a cut set in this manner. So it is fine, it is not violating our rule. The rule is it should cut only one twig and any number of links. Okay, coming to my third twig, I can also consider this. It is also not violating my rule. Coming to my sixth twig, here also I can consider this as one cut set, but I cannot treat this as a cut set. Why? Because here it is cutting two twigs, 1 and 2 and fifth link, so it is violating my rule to form a cut set. So as I discussed previously, this is one cut set I can consider, this is one cut set I can consider, this is one cut set and so on. Coming to my second twig, so I can consider this as one cut set. Okay, so it is cutting my entire graph into two parts. It is only cutting one twig 2 and it's cutting two links 4 and 5. So nowhere the rule is violated. So let me show you. So this is how we have considered the cut sets, and the direction of cut set should be in the same direction as the twig it is cutting. Okay, so considering C1, C2 and C3, C4 are the cut sets forming the matrix. As I told you, first twig should be entered, then link should be entered. Okay, C1 and first twig are in same direction, +1, 2, 3 and 6 are nowhere related to C1, so it is 0. Fourth link is in the opposite direction of C1, cut set C1, so -1. Fifth fifth link is nowhere related to C1 cut set, so it is 0. Next, considering cut set C2, first twig is nowhere related, 0. Second twig is in the same direction as C2, so +1. Third and sixth twigs are nowhere related to cut set C2, so they are 0. Coming to fourth link, they are in opposite direction of cuts when compared to cut set C2, -1. Fifth link is also is in the same direction, so it is +1. Cut set C3 is nowhere related to 1 and 2, so they are 0. Third is in the same direction as C3, so it is 1. I'm sorry, it is cut set C3. So twigs 1 and 2 are nowhere related to cut set C3, so they are 0. Third twig is in the same direction as cut set C3, so +1. And fourth, I'm sorry, not fourth, sixth twig is nowhere related to cut set C3, 0. Fourth link is in the opposite direction as cut set C3, so -1. And fifth one is nowhere related to my cut set C3, so it is 0. Coming to last cut set C4, 1, 2, 3 twigs are nowhere related to cut set C4, so they are 0. Next, sixth twig is in the same direction as cut set C4, so +1. fourth link is also nowhere related to cut set C4, 0, and fifth link is in the opposite direction as C4, so it is -1. So this is how I constructed cut set matrix for this example. Coming to my next example, already the oriented graph is given. I'm considering 2, 3, 4 branches as my tree. So number of twigs are 3, so number of cut sets will also be 3. So here, since 2, 3, 4 are cut sets, this are the twigs. This is one cut set I can consider, this is my second cut set I can consider, and this is the third cut set I can consider. Nowhere the rule is violated. It should contain one twig in any links. Okay, so the direction, as you can see, should be in the same direction as the twig it is cutting. So constructing the matrices, the matrix, cut set matrix, assuming it is C1, C2, C3 as the names of the cut sets. So first twigs should be entered, then links. So the first cut set C1, 2 is in the same direction, 1, 3, 4 nowhere related, 0. First link opposite direction -1, 5, 6 nowhere related, 0. Cut set C2, if I consider cut set C2, 2 is nowhere related, 0, 3 in the same direction, +1, 4 is also not related, 0. First one is in the opposite direction, -1, 5 is in the same direction, 6 is also in the same direction, so both are +1. Now considering cut set C3, 2, 3 branches or 2, 3 twigs are nowhere related, so 0. Fourth twig is in the same direction as the cut set C3, so +1. First link is nowhere related to cut set C3, 0. Fifth link is in the opposite direction, it is -1. Sixth is also in the opposite direction of the cut set C3, so it is -1. So this is how we kind of constructed the cut set matrix for the given graph. So here we have asked to draw the graph for this given network and find the tie set schedule. Okay, so till now we have seen how to construct a tie set matrix and cut set matrix and incident matrices. Now through this example we will see how we can obtain equilibrium equations. So we know how to find the graph, isn't it, by replacing all by line segments, and here I have considered 1, 2, 3 as the tree and remaining branches will be links. So since I have 4 links here, so here you can see he has asked us to find equilibrium equations. Here you can see obtain equilibrium equations based on loop currents. This is what, and also obtain branch currents and branch voltages. Okay, so based on the tie set matrix we need to find the equilibrium equations. First let us try to find tie set matrix. So since I have 4 links here and 3 twigs, okay, so I'm sorry, not 4, 3. There are 3 links and 3 twigs, so I have 3 tie sets, isn't it? So the loop direction should be same as the link direction, and since you already know how to form a form a tie set, so I am just going to move on to the formation of tie set matrix. So first links should be entered, then twigs, as we know the basic rule. Okay, so if they are in same direction, it is plus 1, opposite direction minus 1, nowhere relation 0. So in the first tie set, 4, 1, 3 are related. So 4 is in same direction, 5, 6 nowhere related, 1 is in the same direction, 2 is nowhere related, 3 is in opposite direction. Next, second tie set, 4 is nowhere related, 0, 5 is in the same direction, 6 nowhere related, 1 is also not related to my second tie set, 3 is in same direction, 2 is also in same direction. Now last third tie set, 4 is nowhere related, 5 is also nowhere related, so 0, 6 in the same direction plus 1, 1 is 1 and 2 both are opposite in direction, so it is minus 1, and 3 is nowhere related, 0. So now using this we need to obtain what are the Kirchhoff's equation, okay, KCL and KVL equations. Okay, so remember that the row of tie set matrix will give you KVL equations. Okay, if I consider the row 1, this entire row, if I consider, okay, plus 1 entries are near fourth link and first twig, minus 1 entry is near the third twig. Okay, so the equation will be V4 plus V1 minus V3 is equal to 0. Okay, because 4 has 1, so it is V4, 1 has 1, so it is V1, 3 has minus 1, so it is minus V3. If I consider the second row, fifth link has 1, second and third twigs also have 1, so it is V5 plus V2 plus V3 is equal to 0. Last row, if I consider, minus 1 is near 1 and 2, plus 1 is near 6, so the equation will be V6 minus V1 minus V2 is equal to 0. This is how I can get KVL equation from tie set matrix. Next, we have seen every row, we have considered every row. Now if we consider the column of tie set matrix will give you the relation between loop current and branch current. Okay, so this I considered as I1, I2, IT in capital letters. So since it is 4, I have considered is I4, 5 I have considered I5, sixth link I have considered I6. So depending upon link and twigs, I have considered the branch currents, I mean. Okay, now using the entries we can get the relation. So since I have 1 here, it means that I4 is equal to I1. Okay, since I have 1 here, so again every column I need to consider, isn't it? I'm sorry. Okay, let me go back. Okay, so every column, so in this column I have one only. Okay, only one in this column, so that is I4 is equal to I4. So when I consider my second column, I have plus 1 here, so I5 will be equal to I2. In the third column I have plus 1 between I3 and I6, so it is I6 is equal to I3. Next, here in this I have plus 1 near I1 and minus 1 near I3, so I1 will be I1 minus I3. This column when I consider, plus 1 I have near I2, minus 1 I have near I3, so I1 I2 will be I2 minus I3, and the last column I3 will be minus I1 plus I2. So every column will represent the relation between branch currents and loop currents. So now we'll see how to construct the equilibrium equations based on tie-set matrix. So since we have considered I1 here, 1 here, the current I have assumed as I1. Since this second branch, I have assumed current as I2. So similarly I3, I4, I5, I6, depending upon the designated branch number, considered currents I1, I2, so on till I6. So loop direction, I have considered in the same direction as I told you, based on the links. I have considered tie sets, I have considered the loop direction as well. Okay, so V1, remember, yeah, V1 is related to I1, isn't it? So it is 1 into I1. Okay, V2 is related to I2. So it is in that branch, since I have 2 ohms, 2 into I2. Okay, third branch V3 is 4I3. Okay, fourth branch has 5 ohms, so 5 into I4. Fifth branch has 5 ohms, so 5 into I5. And sixth branch has a voltage source 5 volts and 2 ohm resistor, so V6 will be 5 plus 2 I6. But we already know the relation between branch current and loop current, isn't it? If I take you back, we have already obtained this relation. Okay, so just I am substituting this and replacing all my branch currents in terms of loop currents. So in place of I1, I have substituted I1 minus I3. In places of I2, I have substituted I2 minus I3. In place of I3, I have replaced by I2 minus I1, and I4 I have replaced by I1, I5 I have replaced by I2, and I6 I have replaced by I3. That is what I have obtained in previous slides, isn't it? So substituting these relations in my KVL equation, what was so these were the KVL equations, isn't it, that I obtained previously. V4 plus V1 plus V3 is equal to 0. So just substituting in these 3 KVL equations which we have obtained in previously, and I'll get 3 equations, 3 unknowns. So solving these 3 equations, I will get the value of the loop currents I1, I2 and I3. Okay. So upon solving, I got the values of I1, I2 and I3, but we know the branch relation between the branch currents and the loop currents, isn't it? So thereby I am finding, depending upon the relation that we obtained earlier, all the branch currents I have found out. And since I need branch voltages, we also know the relation according to the equations that we have obtained from V1 to V6. All the values I have substituted and obtained branch currents and branch voltages. So this how we obtained the equilibrium equations based on the loop currents, and correspondingly the solution of finding loop currents, branch currents and branch voltages. So here also graph is given to us, and we are need to find cut set matrix. Here also I need equilibrium equations based on node voltages and branch voltages and currents. This is the same sum that we have seen in previous example, but here we need to find cut set matrix, isn't it? So since it is based on node volt, since we are asked to find equilibrium equations based on node voltages, my source should be of current source type. Okay, so that is why using source transformation, transform this into a current source in parallel with my resistance. Okay, so after doing so, I have obtained the graph and considered the tree and obtained the links and twigs as usual. And for cut set matrix, you know that this one can be considered as one cut set, this here one more cut set, and here also one more cut set. So these are the three cut sets that I can consider. Okay, and the direction, as you know, should be same as the twig direction. Assuming cut sets to be C1, C2, C3, you know how to enter all the entries of a cut set matrix. If both are of the same direction, +1. If both are in opposite direction, -1. If both are nowhere relation, it is 0. So you can check it out to yourselves. The values of the entries that I have shown you, are they correct or not. So after forming the cut set matrix, now we need to find the equilibrium equations based on node voltages. So here the row of every cut set matrix will give me KCL equation. So the first row, if I consider, I have one entry near 1 and 6 and -1 near 4. That is why the equation becomes I1 minus I4 plus I6 is equal to 0. When I consider the second row, I have +1 near 2 and 6. So that is why I have written I2 and I6 in and the magnitude -1 I have near 5. So the equation is I2 minus I5 plus I6 is equal to 0. Now I consider third cut set, third row, +1 I have near 3 and 4 and -1 near 5. So the KCL equation will be I3 plus minus I5 plus I4 is equal to 0. So if I consider the columns, that will give me the relation between node voltages and branch voltages. Okay, as you have seen previously, we have used branch currents in cut set tie set matrix. Here I am considering branch voltages and node voltages. Here capital VA, VB, VC are node voltages, and V1, V2, V3 till V6 are branch voltages. Okay, so depending upon the entries of cut set matrix, we can write the equation. Okay, so every column, one column I will consider, and I have only +1 near VA, so V1 is equal to VA. The second column, if I consider, it is V2 is equal to VB. The third column, if I consider, VC is equal to V3. The fourth column, I have -1 near VA and +1 near VC. So V4 will be VC minus VA. The fifth column has both -1 both near VB and VC. So V5 will be minus VB minus VC. Last column has +1 near VA and +1 near VB. So VA plus VB will be V6. Now using this, as I told you earlier, indicated all the branch currents I1, I2, I3 depending upon the designated branch numbers that we have allotted. So using that, I'll find what is every branch current in terms of both branch voltages as well as node voltages. Okay, so I'll leave this to you for you to analyze. Okay, because it is not so difficult, isn't it? So there's the first branch, so obviously first branch has 1 ohm, so that it will be V1 by 1. Second branch has 2 ohms, so it is V2 by 2. Third branch has 4 ohms, so it is V3 by 4. Fourth branch has 5 ohms, so it is V4 by 5. Similarly, fifth branch has 5 ohms, so it is V5 by 5, and the sixth branch has 5 ohms as a current source 5 by 2 and 5 ohms, so it will be V6 by 5 minus 5 by 2. Okay, that is how I can write my branch current I6. This we already know the relation between node voltages and branch voltages. So using that relation, we can write in terms of node voltages VA, VB and VC also. Okay, and all these that you obtained, these 4 equations and these 2 equations, all we need to substitute in the KCL equation. So KCL equation, we already know that it is I1 minus I4 plus I6 is equal to 0, I2 minus I4 plus I5 is equal to 0, I3 minus I5 plus I6 is equal to 0. So all the values that are obtained previously I have substituted in this in these KCL equations. So I have 3 equations and 3 unknowns. On solving, I'll get my node voltages, correspondingly branch voltages and branch currents. Okay, so this concludes my lecture on the concept of network topology. Thank you.